But anyway, let's share the screen and get started. Let's do the thing again. I can already see it. But we have our solutions now. Just turn it off and on again. Apparently that fixed everything. But anyway, so today we are talking about subsets. And we're still in 6.1. 6.1 is a very long chapter. But yeah, so we are in subsets now, which remember are like sub collections of sets. Because what's a set again? A set, recall, a set is a collection of elements. Nothing more, nothing less. It's a collection of elements where every element in the set is in the set exactly once, and every element not in the set is definitely not in the set. There's no in between. It just either you're in or you're out. Sets are pretty simple that way. They're like a heist movie. At some point, you decide if you're in or you're out. Sets, they decide that from the beginning. That's exactly what they are. Ocean's 11 is a set of 11. The point being that it says a collection of elements. And so loosely, we talked about last time, a subset is a sub-collection of those elements, right? It's just take that collection and then take some elements from that. Form a collection from this collection, right? And that's a subset, basically. That's an interesting way to put it. Never thought of it that way. But anyway, yeah, that's how it is. Take a collection from this collection. That's what it is. The formal definition goes a little more like this. Actually, a lot more like this because it's exact. We say that A is a subset of B. This is the subset sign, remember? If and only if, for all X in A, X is in B. And that makes sense, right? Like if, like for example, this is the set of all my markers. But if I get rid of a couple, this is a subset of that set. But the point is, every marker here had to be in the bigger set. That's just how it works, right? That's what makes it a subset, the fact that everyone in A is in B. So this is what a subset is. I don't think we have any questions on that, but let's get any questions. Perfect. And we're supposed to do this later, but I will just mention it right now. Definition. We say A is a proper, this is the word proper subset of B if and only if A is a subset of B, but B has at least one element not in A. So it's a proper subset. This is like if you ever watch British TV, they say proper to mean like actual, like legit. Proper subset, we call them proper because it kind of fits their idea of subset as an actually smaller set. So a regular subset, notice that the set itself is like every set is a subset of itself. Like this is a set of markers. This set of markers is a subset of this set of markers, right? For example, the set 1, 2, 3 is a subset of the set 1, 2, 3, right? Because everything in here is in here. So it is a subset in the sense that it's a collection formed from this collection. But I mean, it's not really what we think of when we think of subset. We think of subset, we think of something actually smaller, right? Doing something different. And so that's why we call, say, A is a proper subset of B. If A is a subset of B, but B has at least one element not in A, so A really is a smaller thing than B in a certain sense. Now, notice here, by the way, you'll see that this is going to be a pattern. My diction here is very precise. So here I'm saying B has at least one element not in A. You might ask, well, why don't I just say why not say B has one less element than A? And the reason being, because then this gets into a whole problem with infinities, right? For example, the natural numbers we're going to show are a proper subset of the rational numbers, right? Every natural number is a rational number. But it's definitely a proper subset because Q contains elements that aren't in N. But the issue is Q and N are both infinite, right? So like for finite sets, like saying that 1, 2, 3 is a proper subset of 1, 2, 3, 4. Well, then it kind of makes sense to talk about one less element. That says 3 elements, this says 4 elements, so this is one less element in this. But like in this case, they're both infinite. So infinity minus 1, is infinity minus 1 less than infinity? See what I'm saying? We're actually talking about infinity a lot later. But anyway, for now, we're just not even going to deal with it. We're going to get around the problem, but not even mentioning the number of elements. We're just going to say that B has at least one element less than A, or one element not in A. So anyway, these are subsets. These are proper subsets. Yeah. I guess the formal way you'd write this is you say A. So we write it like that. We write A with this kind of sideways U, but not with this. Actually, sometimes people write this. Actually, let's do it this way instead, just to be clear. There's multiple different notations, but let's use this one where people do this. They write the normal proper subset sign, but they slash to this bottom part. The reason being that bottom part kind of tells you could be equal. It's kind of like the less than or equal sign in like regular numbers, right? Less than or equal sign here, it's a less than sign and an equal sign. That's the same thing that this proper subset sign is. And so this regular subset sign is. So to make a proper subset, we could take the subset sign and slash through the equals to say it's not actually equal, it's not the same set, it really is a smaller set. So A is a proper subset of B if and only if A is a subset of B and A is unequal B. We'll talk about what this means in a second. Maybe instead we should say there exists an X in B such that X is not an A. Okay, that's a very long-winded and weirdly rich story of proper subsets and subsets. We went around in circles, a lot of tangents. Anyway, we're back. So the point is, these are subsets, these are proper subsets. Every proper subset is a subset, it just contains less elements in the set it comes from. So, something like that.